Determine the area of the triangle formed by the three lines whose equations are given to us. We have y equals to x, y equals to 2x, and y equals to 3x plus 4. Let us begin. So here, let's say we have the lines L1, L2, and L3. Let's say L1 corresponds to the line with equation y equals to x. L2 corresponds to y equals to 2x, and L3 corresponds to y equals to 3x plus 4. Now, what we'll do, in order to find out the area of the triangle formed by the intersection of the three lines, so we'll suppose that let L1 and L2 intersect at the point A. Then we have the line L2 and L3. Let's say it intersects at the point B. And then we have line L1 and the line L3 intersecting at the point C. Now, our goal will be to determine the value of ABC. Before that, what we'll do, we'll try to find out the coordinates of point A, B, and C. Once we have the coordinates of A, B, and C, we can easily find out the area of the triangle. Okay, to find out the coordinates of A, we'll begin by first finding out the coordinates of A. The coordinates of A is going to be simply the point of intersection of the line L1 and L2. That means we need to solve the equation of the line L1 and L2 to get the coordinates of point A. Okay, fine. So that's a very simple task. We have y equals to x, and we have the line L2 given by y equals to 2x. So what we can do, we can equate 2x equals to x since y and y's are equal, which implies x equals to 0. Now we can put x equals to 0 in either of the two equations, so we get the corresponding y value as 0. That means that coordinates of point A, that's going to be 0, 0. Now let's find out the coordinates of B. So coordinates of B is simply going to be, so we'll have to take the equation of the line L2, so that's y equals to 2x, and we have to consider line L3, which is y equals to 3x plus 4. Okay, so let's do one thing. So here we equate 2x with 3x plus 4. So solving for x, we get x equals to negative 4. So we have obtained the value of x. Now, if x equals to negative 4, then the corresponding y value, we can use y equals to 2x. That's going to be equals to negative 8, which means that the coordinates of point B, that's going to be negative 4, negative 8. And then finally, we'll find out the coordinates of the point C. To find out the coordinates of point C, we need the line L2 and we need the line L3. So here L1 corresponds to y equals to x, and we need L3. So L3 corresponds to y equals to 3 times x plus 4. Okay, now what we'll do, we're going to equate them, and that's going to give us x equals to negative 2. So if x equals to negative 2, corresponding y value, that's equals to negative 2 as well. Fine, so we have successfully obtained the value, the coordinates of C, so that came out to be negative 2, negative 2. Okay, so now we have the triangle whose coordinates of the vertices are known. So let's find out the area of the triangle. So area of the triangle ABC, that is going to be equals to 1/2 times the determinant of, so what we'll do, we will consider the coordinates of A in the first row. So let's say in the first row, first column, we use 0. Then in the first row, second column, we take the y coordinate of A. And then in the third column, in the first row, third column, we consider 1. Then in the second row, we're going to consider the coordinates of B. So here we'll start with the x coordinate, negative 4. That will go into the second row of first column. Then in the second row of second column, we'll use negative 8. And the second row of third column, that stays as 1. And then finally, we consider in the third row the coordinates of point C. So we have negative 2, and 1. Okay, so now what we'll do, we're going to expand this determinant. So that is going to be equals to, so we have 1 multiplied to negative 4 times negative 2, so that's going to be positive 8, minus negative 8 times negative 2, so that's going to be negative 16. So that's going to give us half times absolute value of negative 8. So negative 8 means we simply have 8 over 2. So that's going to give us 4 square units. So that is going to be the area of the triangle.